Today we discuss parallel lines. We'll learn the definition, equations, and look at some examples. Let's begin. Parallel lines are two or more lines that are the same distance apart, never merging and never diverging. We recall that lines are never ending, so parallel lines continue forever in two directions, always the same distance apart. A single existing line can have an infinite number of parallel lines too, simply by picking a point not on any existing line and constructing a line parallel to all the existing ones. To be two parallel lines, both lines must exist in the same plane. This differentiates them from skew lines, which exist in three dimensions, two separate planes. Parallel lines are by themselves very interesting, but when you take segments of them, you can construct many polygons. Think of squares, parallelograms, rectangles, and trapezoids. They all have parallel sides. To symbolize parallel lines in geometry, we use two upright or slightly slanted lines, like this. Both of those statements tell us that line AT is parallel to line UP. Constructing parallel lines can be done with a straight edge, a pencil, and plain paper. If using a ruler, this is a one-step process. Lay the ruler on the paper, holding it carefully so it does not slip. Trace each edge of the ruler. You're done. Move the ruler and you have parallel lines. You can label them, identifying each line with two named points and placing arrowheads at the end of the two lines. You can also construct a line parallel to an existing line passing through a single point not on the line. Pause the video and follow the steps in the How to Construct Parallel Lines section of the article below to try it out yourself. You'll need a drawing compass, plus the plain paper, pencil, and a straight edge. Now let's look at graphing parallel lines. In coordinate graphing, parallel lines are easy to construct using the grid system. A simple equation can provide all the information you need to lay out a line. 3x minus y equals -4. Our line is established with the slope-intercept form, y equals m times x plus b. So we solve the first equation so it is changed to the slope-intercept form. Subtract 3x from both sides. Simplify. Divide both sides by -1, and you get y equals 3x plus 4. Now add another line that keeps the x value the same. You only need to retain 3x, so you could write y equals 3x minus 5. This new line is far to the right of the first line, but is exactly parallel because the x value determined its slope. Same x value, same slope, both lines parallel.